Hello, my name is Centera Getty, and this is my presentation over SQL Data Manipulation Language. So the outline on what we're going to be going through is what is SQL Data Manipulation? Why is this essential? Some of the command explanations. We're going to go over some of the line rules. And then we're going to be talking about some built-in functions, aggregate functions, conversion functions, mathematical functions, some of the date functions. And then, of course, why is this important? So what is SQL Data Manipulation Language? This is a subset of a structured query language called SQL Data Manipulation Language and is used to work with data that is kept in relational database management systems. So users can obtain, insert, update, and delete data from the database tables using DML commands and actions. These commands are crucial for database management because they let users carry out a range of tasks to preserve data integrity, apply business rules, and retrieve valuable information. So, of course, our data isn't important unless it's correct, unless it's right and is able to provide a purpose. So that's the whole reason data definition language and this combined language exists. It helps us specify the structure of database objects like the tables, indexes, and constraints. They're frequently used in tandem with the DML statements, and they're fundamental building blocks for relational database management. And they're often used together, and the commands are fundamental to manipulating data within relational databases. And they allow users to interact with and manage the content of database tables effectively. Some of these primary operations are select, insert, update, and delete. So select is retrieving data from one or more tables. Inserting, we're adding new rows into the table. Update, we're updating existing data in the tables. And deleting is where we're removing rows from the table. So we've already talked about the first four. The ones that are listed that we have not talked about is merge, which is combining it together, call, which executes a stored procedure, or user-defined function. So you can have specific functions within your table or your database, especially if it's something frequent that you use. You might as well save it and then use this to make your life a lot easier. You got fetch, which retrieves rows from a cursor result set one at a time. And then exist, it checks underneath the condition of if something does exist, then, doing whatever you need to perform. And then lock table, you can lock a table so that way you can control access during critical operations. And then some of our simple manipulation line rules. So each clause in a statement should begin on a new line. So this here starts on a new line where we got select, and then we got the first name, last name, and phone. These are all column names. And then we got from the employee's table, order by the last name. If a clause has several parts, they should appear on separate lines and be indented underneath the start of the clause to show the relationship. Uppercase letters are used to represent reserved words, so select from in order, obviously my reserved words. And then lowercase letters are used to represent user-defined words. That's what the column names are, and the table names. Those were user-defined. It's not universal between any database that you go into. It's specific off the data that you have inputted into your database. All right. So commands often involve criteria or a condition specified using the following clauses. So we got the where clause, which is used to select, update, and delete statements to filter rows. We also have the order by clause, which is used with select statements to sort the result set based on one or more columns. So this previous example, this was a select in conjunction with the order by. We have the having clause, which is used with group by to filter grouped rows, and then join, which is used with select statements to combine rows from two or more tables. Then we got null and not null. So null represents nothing. So if something's not there, just doesn't exist in the database, it doesn't exist in that row. And we build that condition that that's okay, that is accepted. Then there's not null, which is the opposite. So that means something has to be in there, and it has to be based off whatever that constraint is for that data type that is accepted into that row. And it will not let you make an entry until that is fulfilled. And so we do now have some special types of functions, and so these are called some wildcards. So if you use a percent sign, it does any string of 0 or more characters, and underscore any single character, brackets any single character within the specified range or set, and then the brackets with the up arrow in the middle is any single character not within the specified range or set. So for example, we're going to use this percent sign. So this is showing the select and then the where clause, with showing the last name and employees. And so we're going to be searching in the last name column with this percent sign wildcard with the MC. So it's going to pull any employee with the last name starting with MC. It's going to pull up for us. There is some built-in functions in the SQL server, and that's aggregate, conversion, date, and mathematical. These are the most common, but then there is also string, system, and text and image. We're not really going to get into, I'll explain string a little bit, but we're not really going to touch system and text and image in this presentation. The main ones we are going to be talking about is the aggregate, conversion, date, and mathematical. So for the aggregate functions, there is the average. This returns the average of all values. Count, it returns the number of non-null values in expression, so it counts it for us. And then count asterisk returns the number of rows. It takes no parameters and cannot be used with distinct. Then we got max, which returns the maximum value in the expression. Minimum returns a minimum value in the expression, and then sum returns a sum of all the values in the expression. So an example is we're going to be using the average and then the count. So this first one shows the select average price from the books table. And so when we put this in, it's going to come back as the average title price that's listed in our books table. Count, it's going to be counting the amount of publishers that we have in that current table. It's going to count the amount of rows, and it's going to come back as the number of publishers with that total of number of rows that we have in that specific table. Conversion. So this conversion function transforms one data type to another. So in this example below, a price that contains 2 nines is converted into 5 characters. The syntax for the statement is select, the date is, and then it converts to varchar 12 into get date. And so that's what it's showing here is the select convert statement. We're using the title ID and then the price from the books table, and this is where we are converting. Date. So the date function produces a date by adding an interval to a specified date. The result is a date time value equal to the date plus the number of date parts. So if the date parameter is a small date time value, the result is also a small date time value. And so here's our chart that shows the date parts and abbreviations recognized by the SQL server, and then some of the acceptable values for those abbreviations and date parts. So for example, you got year with the YY showing 1753, and then 9999. I'm not sure why it starts with 1753, but it starts with that and it continues to 9999. Quarter, 1 through 4, month 1 through 12. So these are some examples with the dates. So this first command returns the number of day part boundaries, and it shows the date diff, day, hire date, and then the November 30th, 1995 from employees. and then the date add functions, which selects the date add where it's day 3 and then their hire date from employees. So this is an example of a mathematical function. So this is showing what the current price would be if all the prices were increased by 10% in our books table. String, it's a character string in a data type that's used in programming in databases to represent a sequence of characters, including letters, numbers, symbols, and is fundamental for storing and manipulating textual data. All right, so now it's time to put some of this to the test on some of the stuff that we used, and just try to implement everything. So I'm currently working in Azure Data Studio. I'm in a Postgres server, so some of my codes all of my codes are going to be based off the Postgres SQL. And then I've already created this e-commerce database, and some background on that is that we are managing the database for a popular e-commerce website that sells a wide range of products. So this website actually collects a vast amount of data on user interactions, including page views, product searches, and purchases. The task is to analyze user behavior and provide insights to improve the website's performance and user experiences. So I'm going to go over 3 scenarios. So it's going to be a simple, moderate complexity, and high complexity with query based off this database, just to run through some of the stuff we've already talked about. So to start off with a simple one, this is going to retrieve the total number of users in the users table. And just for time's sake, I did already go ahead and write these out just so I can copy and paste. All right. So based off it says there's 25 total users, which is pretty easy, right? So make it a little bit more difficult. We're actually going to calculate the total number of page views per user. I'm going to highlight the specific code. All right. And so this shows the user ID and the name, and then the total page views. And you can still interact with this. So if I just want to see the most number, then I can put 2 in, clear. If I just want to see the ones with the least amount. So of course this would come in handy when working with a larger data set. Thankfully there's only about 25 users in this one, so it's pretty simple with 1 and 2, but if there was a lot of variance in those numbers, this function can definitely help you out a lot. And then of course, if we want to figure out something with a large amount of data set, that would be a little bit harder for us to calculate, but writing it into a code to make our lives a lot more efficient. So with this code, it's going to identify users who made purchases, including their total purchases and total page views. So this can help us identify any correlations and patterns within this data set. All right, and so this is the select user ID, you name, and it asks us to do the counts, left join, group by, and order by. And of course the total purchase is going to be descending, which means it's going to be the most number up and then going down from there. And it's going to be by purchases. So we should see the people with the most purchases first. And that's what we do. So Michael Johnson 2, David King 2 and 2, Jessica Miller 2 and 2, and John Doe 2 and 2. And of course it goes down from there, but it calculated everything based off the total purchases first and then page views. All right, so impact of DML query complexity on performance. So I just went over some that were easy, middle, and then kind of like harder. And so the complexity of the DML queries refers to the intricacy and sophistication of the operations they perform on the database. I understand looking at it at first can be very overwhelming, but the more you play with it, the more you kind of understand how this language works. And the more comfortable you can be with presenting your data, and then also understanding how to dive more and more and then do kind of everything with this language. So the complexity can arise from various factors, such as a number of tables involved, the complexity of conditions and where clauses, the numbers of joins, and then the use of aggregate functions. So, of course, I always recommend starting off with a smaller data set and then adding more and more and then playing with it from there to really understand and see how you can join things together, setting up primary keys, putting in some of those where clauses, how to do those average functions, and really being able to understand those patterns and kind of outliers within your data set to make whatever job you're trying to do a lot easier. So on large data sets, complex DML queries can significantly impact performance. So they may require more computational resources. And of course, with the larger data set, with more amounts of data that the system has to go through, it can take longer to execute. And of course, with the more data, it comes along with consuming more memory and disk space. In addition, that as the complexity of DML queries increases, the DBMS needs to perform more intensive processing to retrieve, manipulate, and organize the data, which does lead to slower query execution times. So essentially, the more data that you are working with in a set, and sometimes the more complex the queries can be because it has to go through so many steps, it can slow down the process on trying to get all that information back versus some of the simpler queries we may ask it to do. So that goes into our common performance issues, which the ones we've already discussed is a slow query execution. So the more complex your queries are, it can lead to slower execution times, causing delays in retrieving results. And overall, this can affect user experience and overall system responsiveness. And then resource consumption. So it's going to consume more memory, disk resources, and it leads to resource contention and degraded performance for other database operations that may require like more storage. Indexing. So indexing is a technique used to improve the performance of a database query by efficiently retrieving the data. So an index is a data structure that organizes the values of one or more columns in a table, allowing the DBMS to quickly locate rows that match certain criteria that you put in there. So by creating indexes on columns frequently used in where clauses or in join conditions, the DBMS can significantly reduce the time required to search and retrieve data, thus improving query performance. So essentially, we're all more familiar with something the more we do it. So it's the same thing here. If you create an index on perform a system a command line that you perform often, you put that in as one by an index, the system's going to recognize it a lot easier. And then it's going to make everything a little bit quicker. So implementing indexing. So consider a scenario where you have a table named sales data and it contains millions of rows. You frequently run queries to retrieve sales records based off the customer's last name. So in this case, if we created an index on the last name column, it can significantly improve query performance. And so that's this is a code on what we would do, and the code we would be creating for, or the index that we're creating for, is going to be pulling sales data with the last name Smith. And because we have this saved and we're creating this index, it's going to result in a faster query execution. So then that brings us into importance of physical and materialized views. So physical or materialized views are pre-computed result sets stored as tables in the database. They allow for optimization for query performance by pre-computing and storing intermediate results, reducing the need for complex calculations during query execution. So by storing frequently accessed data or aggregations in materialized views, queries can be executed more efficiently, leading to improved overall performance. So, for example, when I was coding in the e-commerce database and those codes that I submitted on the video, I could have saved all of those end results, those tables it was giving me, as saved views. So those saved views mean it would have saved that as a table itself, and so then it would make everything quicker for improved overall performance because it would already be there versus me having to keep inputting those codes every single day and trying to pull them up. So creating materialized views. So suppose you frequently generate reports summarizing sales data by region and product category. So instead of performing complex aggregation queries each time, you can create a materialized view to store the pre-computed results. So this would be the code is the create materialized view, MV sales summary, as select the region and product category. We're trying to find the sum from total sales. And we want it grouped by region and product category. So instead of having to put this in every single day, we can save it, and then based on that being saved, then that would help make everything more efficient. And of course, after we put this code in order to make sure that we are refreshing to make sure we're seeing the most up to date, because of course, these are saved views. So you do have to make sure you schedule periodic refreshes or be able to manually refresh it as needed. This is the code that you would do to refresh it because you don't want to be looking at old data. And then creating physical views. So let's say we have a named employees that stores information about employees, including their IDs, names, departments, and salaries. We want to create a physical view that provides a simplified summary of employee data, including only their names and salaries. So we use the create view select statement. We specify the employee name and salary, and we retrieve this data from the employees table. So now whenever we query the employee summary view, it's going to retrieve the data from the employees table and return only the employee name and salary. All right. So that is it when it comes to, SQL Data Manipulation Language, and then everything that we, put in and we talked about. Here are some of the resources. Overall, I just hope everyone learns, about coding, how important it is, and using these command languages, the endless opportunities, because, we've only touched on a few in this presentation, but really understanding how deep this can really go, and especially working with those larger database systems on how easy this code can be compared to trying to perform these on your own. Databases and command language has taken us a long way. And the more we understand this for SQL, that also corresponds to other databases as well and other command line language. So thank you so much for your time. I appreciate it, and I hope you enjoyed the presentation.